If math has been driving you crazy, or if you're finally admitting you're lazy, and your test grades have been dropping, it's time to get your arrows popping. Hello everybody, this is Mr. Witt. That's right, ladies and gentlemen, it's Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about logarithmic properties. We already have Tony and Noah in the house already to join us. We have the King Kyrie. That's what's going on. Hi, Mr. Witt. Me and my friend Lion Irvin love you. I love you too. Angry Hermit is in the house saying hello already, guys. That's right. We are in the house in full effect with logarithmic properties. Amen, amen. Absolutely. Let's get this thing crack-a-lacking. First thing today, as we are having a productive day today. Yes, we are. We're going to continue to do the same and have a productive day with my people in the house as we look at some logarithmic properties. We got Lewis in the house talking about he's alive. Just to remind you guys that when you want to search for some free math tutorials and you want to have some good free math tutorials, go ahead and subscribe to Fort Bend Tutoring. Click on that subscribe button. Click that bell icon to get notified when we have new and free content fresh for you. That's right. That's right. Angry Hermit, you are alive. You need to stop those lies. Stop those lies. All right. So we have everybody. Let's get started. We got the chat up and running. Yet we do. And we have our logarithmic properties and definitions to begin with. Let's go ahead and get this thing underway, guys. So with the following, let's go ahead and check it out real quick. We have the logarithmic properties and definition. We have our conversion right here. This is the first thing I'm offering up to you guys. It's the conversion. That when you have logarithmic form of an equation, y equals to the log of base b of the argument x, it's going to be equivalent to the exponential form, which is going to be b to the y equals to x. Yeah, where y is the logarithm, that b is the base, and that x is the argument. That's right. Tony, don't tell me that, man. I hope that's not true, brother. I hope that's not true. All right, let's keep it going. Here we have an equivalent property for logarithms and for our exponents here. That if b to the y equals b to the y, that implies that x equals y. Yeah. And not only that, the natural logarithms, guys, when you see your natural logarithms, that is equivalent to have your logarithm in base e. What's going on, Saya? How you doing, sir? Good deal. And then finally, log of x. When you see that, that is most commonly known as the common log. When you see log without a base showing, you may assume that it's in base 10. Yeah, that's what's going on. That is what's going on as we begin with the logarithmic properties and definitions. Let's continue on here. Let's look at some basic properties of logarithms. All right, good stuff. I'm doing good, Saya. I'm doing real good today because you guys have joined me today. Epic Levy is in the house. Levi, thought I'd join because I'm going to have to learn this eventually. Exactly, Epic Levi, because that's a smart move on your part, sir. Good thing you're joining us today as we're looking at these basic properties of logarithms. Here in number one, log b of the argument one, I should say, equals to 0 because in exponential form, it would be written as b to the 0 equals to 1. There you go. Yeah. Number two, log base b of the argument b equals 1 because in exponential form, you would have b to the first power equals b. Exactly. So not only are we giving you the basic properties, we're also giving you the why behind it. In other words, the proof as to why the logarithmic property is what it is. That's right, giving you guys some good foundation for logarithms. Number 3 here, when we have log of base b of the argument b to the x, the result here is x because, once again, in exponential form, if you were to convert this would read as b to the x equals to x. And as earlier we talked about, when your bases are identical, the exponents must be equivalent to one another. So therefore, you would end up with just x equals to x to verify that this result should equal to x. Amen, amen. That's right. Batuga, 1:19 a.m. in Mongolia. Just to watch with this awesome dude teaching us live. That's what's going on. How you doing over there from Mongolia? Thank you for joining us today. I appreciate that. Problem number 4, guys. If we have b raised to the power log of base b of x, this is equivalent to x because when you write it in exponential form, all right, you would end up with log b to the x equals to log b to the x. There you go. And therefore, x would equal to x. Amen, amen. In other words, if you were to put the log of both sides, you would end up with that result. Amen, amen. Yeah. Good stuff. Tony, I don't know what you're saying about this today, man. That's a touchy subject, sir. My mom passed due to that. All right. Good deal. So let's go ahead and continue on. All right. So hopefully no jokes is about that. We have properties of logarithms. Here we're continuing with the following properties, guys. When you have properties of logarithms, let's let b, x, and y be positive real numbers where b does not equal to 1. Okay. We are looking at number 5 here, where it states that log of base b of the argument xy, this is the product property, guys, the product rule for logarithms, that it can be expanded into log base b of x plus log base b of y. There you go. All right, I'm assuming Angry Hermit. I'm assuming that he is. Then we have log base b of the quotient x divided by y. This is equivalent to log base b of x minus log base b of y. This is called the quotient property of logarithms. Continuing on, we have problem number 7, where we have log base b of x to the p. If p is any real number, you would end up with p log base b of x. This is the power rule for logarithms. There you go. All right. Rest in peace, Adam West. That's right. The first Batman that I knew. Good deal. If he has passed, may God bless him. All right. Good deal. And peace and blessings to his family as well. All right, guys, let us dig into some problems. How about that? All right. Big ups to Adam West. Okay, good deal. Here we are asked to convert to exponential form, guys. We are converting to exponential form. We have problem number 1. It says when you have log base 9 of 81, the argument 81, this equals to 2. They want us to convert this into exponential form. Recall that when you're converting into exponential form, all you have to do is take your base, which in this case is 9, and raise it to your value on the right side of the equal sign here. So that'll be 9 squared, and then set this equal to the argument 81. And there you have your exponential form. There you go. That's right, Saya. That's right. We're here to learn logarithms today. So as far as your exponential form for problem number 1, this is the answer here. So we're going to put a red box around this, guys. That's exactly what we're going to do. Yeah. Red box in it. That's what we have. So Noah, we are converting the logarithmic form into exponential form. That's what we're here to do. So you would convert it into the base of the logarithm, which is 9, raised to your power, which you will find on the right side of the equal sign. And then you will set that equal to the argument, in this case, 81. That is how you convert from logarithmic form into exponential form. Amen, amen. Let's continue on. All right, we have problem number 2. This looks like we have a common log, guys, because we don't have anything visual showing us what our base is for this logarithm. So when you don't see anything at all here as a subscript, then you may assume that the base is 10. So we're dealing with a common logarithm, which means that our base is in 10. So therefore, our conversion into exponential form is going to be your base 10 here, because it's a common logarithm, raised to the exponent, -4, and this will equal to the argument, which in this case is 1/10,000. And here you have your result for problem number 2. Amen, amen. That's right. So, Angry Hermit, you're absolutely right. The base is 10 because it's a common logarithm. So anytime they don't show you, they don't visually give you a cue as to what, or a clue for that matter, as to what the base of the logarithm is, you may assume that it's in base 10. We are red boxing this. And there we have it for problem number 2. Let's keep things moving, guys. I have quite a few problems for you today. All right, quite a few problems for you today. And just to let you know what we'll be doing over the next few weeks, the previous weeks we were actually reviewing for a lot of end of course exams, a lot of final exams, and we were dealing with second semester exams the previous weeks for college, middle school, and high school classes. All right, secondary classes. But now we're going to be focusing on a lot of different various topics from college algebra, aka algebra 2 courses. All right, and this is one of them, logarithmic properties. All right, so they're not going to be in any particular order. I know what order they're coming in, but for you, they're going to be in pretty much a random order. All right, there's a reason for the season. There's a method to my madness, but it's nothing I need to necessarily share with you guys. But I will just let you know that we'll be doing some random topics, math concepts from college algebra, aka algebra 2 courses. Okay, and that's what we'll be digging into in the weeks to follow. All right, Angry Hermit wants to know what's next week. Then I don't know necessarily. I do have an order, but I don't have it memorized. Angry Hermit, just letting you know it'll be another random topic from college algebra. All right, that I can promise. All right, good deal. And in addition to that, I'll be doing some more studio videos. So there'll be some random videos that's not necessarily even dealing with college algebra that I'll be uploading that I won't be doing live. All right, so you got a lot of new content coming up over the summer, guys. Saya says, what we're going to learn? Are we going to learn integration next week? We will be doing integration over the summer. Sure thing, Saya, but that's not going to be over the live stuff. All right, we won't be doing any of that live. All right, sorry. So the first thing we're going to talk about in problem number 3, guys, is we have the natural log of 1 equal to 0, and they want us to write this in exponential form. We're going to first of all recognize that the natural log here is equivalent to log of base e with the argument 1 that equals to 0. So written this way, we can go ahead and convert this into exponential form by stating that our base is e raised to the 0 power, that right side of the equal sign there, and this is going to be set equal to the argument 1. So as far as our exponential form is concerned, we have e to the 0 equals to 1. Birdspin Poi says, I'm in elementary algebra. We start logarithms next week. Would I benefit from watching this? Absolutely. Yeah, this is the foundation for your logarithms, Birdspins. Angry Hermit said, let's do statistics. I know how much you love statistics, Angry Hermit. You really hate me if you want me to do that, because I can't stand statistics. You know I can't stand it, girl. All right, so Angry Hermit is being feisty already, guys. Giving me a death wish of statistics. I can't even say the word, let alone do the problems. We have problem number 4 here, guys. Problem number 4 is up in your face as we're asked to convert from logarithmic form to exponential form. We have log base a of b equals to c. Therefore, the exponential form of this problem is going to be a, your base, raised to the right side of the equal sign, and this will equal to b, and we have our exponential form. You better put this in a red box. That's right, red boxing it. That's what we got. That's what we have. That's exactly what we have. You know what I'm saying? Okay. Okay. Just want to make sure that you knew that that's what was going on. So now, guys, check me out. Check me out. Good job, Angry Hermit. That's what's going on. Good job. We have convert into logarithmic form. We're doing the reverse now, guys. We are doing the reverse. We are converting from exponential form into logarithmic form. Oh, yes. So starting out with conversions for our problems for today, we now are asked to convert into logarithmic form. Here we go. Let's go ahead and get this started here. We have the base being 2. So we're going to say log of base 2 with our argument being the right side, which is 32, set equal to the exponent, which in this case is 5. So here we have logarithmic form of our exponential equation for number 5. We're going to red box this. Oh, it's over. It is over. See, we are just converting at this point, guys. We are just converting. Noah says the main idea, guys, is to convert logarithmic forms into exponential form or vice versa. That is true for now, Noah, but we'll be doing some more shortly. That's right. Bird Spin. Good job. Good job. Very good, Bird Spin. I see you, Angry Hermit. Let's keep this going then, guys. What about problem number 6? What you going to do with that? With problem number 6, we have the quantity 1/5 raised to the we have the quantity 1/5 raised to the negative third power. This equals to 125. We are asked to convert this into logarithmic form. So our base in this case is going to be 1/5. This is going to be set equal to, not set equal to, by our argument here, is going to be 125. That's a cool looking one. This is going to be equal to the exponent negative 3, and done. And done. Say is saying true. He's co-signing. He's co-signing in the chat there. Let's go ahead and fix this red box here. Let's go ahead and fix this red box. That's what you want to do. There you go. We got a red box around our answer. Oh yeah. Oh yeah. We're gonna get some things accomplished today. We're gonna get some things accomplished today. All right. Let me show everybody some love here. Let y'all know that you had not lost in the ether. That I see you. That's right. Bird Spring is in the house. Anchor Hermit, I got the same answer. It's in the house. Chat is in effect. There we go, guys. There we go. Let's go ahead and continue here with problem number 7. For those of y'all that thought I couldn't count, there's problem number 7 right there. We are asked to write this in logarithmic form. Oh, yes. So our base is e here. So you can say that you have log base e of the argument e and set that equal to 1. You sure can. But even better, you can showcase the fact that log base e is equivalent to the natural log of e, which equals to 1. All right. This will be coming in handy, guys. Keep this in mind, that log of e equals to 1. That'll be used a lot in simplifying equations, expressions, and the like. That when you have the natural log of e, it equals 1. There you go. All right. So this is the logarithmic form. Either of these actually is the logarithmic form of the equation, to be honest with you guys. Either of these is interchangeable. It's just that if you're lazy like me, you're going to go with the shortened version and write it as the natural log of e equals 1. There you go. Yeah, there you go. And you would see it written this way, more often than the other. But the other one is just as true. So if you prefer, you could write it that way. Very good, Bird Spin. Very good. I see you coming in here, Bird Spin, showing off today. We have problem number 8, guys. Problem number 8. That's right. The natural log cancels e. You can go ahead and say that, and we know why now, Lewis, because those things would simplify in that manner for that reason. Absolutely. Batulga's in the house with their answer already. All right, for number 8, good job, Batulga. All right, Batulga, I like the way that you put that number 8 there, so I could know that was the answer for problem number 8, and that you weren't talking about number 7. I appreciate that. So as we move into a logarithmic form for problem number 8, we have log of base m. All right, and remember, guys, your variables must be in the same format as you see them in the original problem. See, I messed up because I made a lowercase m. That m needs to be a capital M as you find it in the original problem. All right, so I made a mistake there, so I corrected it. So we have log base m, that's a capital M. All right, our argument here is capital N, and this should equal 3. And this is going to be your result right here. All right, so Angry Hermit, the only thing I would change up there is that your N needs to be a capital N. All right, because this is an exact science here. Every variable could mean something different. So any difference in the way your symbols look for your variables means that that could potentially be a different variable. So with this exact science of mathematics, we have to make sure, all right, that you have every variable identical to the one that was given to you in the problem. All right, keep that in mind, guys. I know it's the little things, right? But that's the little things that'll get you. So you got to keep that in mind. All right, guys, I wanted to remind you guys that I am available. Fort Bend Tutoring is available for paid online tutorials. You can set those up today. That's right. You can set them up at tutormemath.net. So we offer not free. Let me fix that. Our free content is on the YouTube channel. There you go. Like live content right now is free. However, if you want a one-on-one session with me, Mr. Witt, or one of our qualified tutors, you can check us out at tutormemath.net as we offer the service of one-on-one tutorials online using Skype or FaceTime. All right. So check that out. Get set up. We can see each other face to face finally, some of you guys, and I can assist you with your studies. Amen, amen. Get some things straightened out for you, and you get to ask me your questions one-on-one. Noah says he wants to become a pilot, so that's why he watches your vids to get as much knowledge of mathematics as possible. Plus, he just likes you. Well, tell Noah I like him too, Tony. That's right. That's right. So you and Tony, I like you guys. I appreciate you guys. I appreciate your patronage as well. All right. And don't forget, I do realize that you guys are one of the patrons of Fort Bend Tutoring because you guys have donated on several occasions. I appreciate that. Angry Hermit is in the house ready to move on to some more problems. Let's go ahead and do just that, guys. Let's go ahead and do just that. We don't want Angry Hermit getting upset with us, guys. Let's get back to business. We have problem number 9. We are asked to simplify now. So this is when you can take from any of those properties and definitions that we talked about earlier in the video here, earlier in the stream, and we can apply those to simplify these problems. And what's so good about it is that you don't even need a calculator to make this happen. Oh, no. You don't need a calculator at all. All right. So Raul comes in and says that the answer to problem number 9 is 2. Batoga already says that the answer is 2. All right. Raul is coming in with the answer for problem number 10, saying that the answer is -8. Obina is coming in saying hello. Well, hello to you, Obina. Hello to you. Let's go ahead and look and see what happens here with problem number 9, guys. With problem number 9, we have the following problem. We have log base 3 of 9. The argument is 9. Well, one technique that you can use in order to simplify these problems is to try your best to rewrite the argument with that same base of the logarithm. So since our base of the logarithm is 3, I want to see if I can rewrite the number 9 using that same exact base. So we could rewrite this as the log in base 3 of the value 9 in the form of 3 squared. And due to one of the properties that we saw earlier, anytime your argument and your base is identical, all of this will cancel out to give you the exponent, which in this case is 2 as your final result. And this is our answer. We are red boxing it. So therefore, my main man Raul was correct. Batoga is correct. Very good, guys. Very good. Obina's coming through with the answers. Correct, indeed. Let's go ahead and verify what these answers should be for problem number 10. All right. So for our answers in problem number 10 here, for our answer in problem number 10, for the problem number 10, let's get it correct here. There we go. For problem number 10 here, we have the logarithm, the natural log of 1 over e to the 8th power. Well, the first thing I would do in this problem, guys, is I'm going to rewrite this as the natural log of e to the -8th power. That's exactly what I'm going to do. Then, once I have this, we could show, if we wanted to, that our bases are identical, that the argument's base and that the logarithm's base is identical, because this could be rewritten as log base e of e to the -8th power. And as we saw earlier in the stream, we saw that our property here showed that anytime our argument's base and the base of the logarithm is identical, once again, those will simplify to give you the exponent as your result, which in this case is -8. All right. That's what's going on. Obina says natural logarithm is in base E, not 10. That is correct. Natural logs are in base E, and that's what I showed right here, Obina. We have log base E of e to the negative 8th power. All right? That is exactly right. Good deal. All right, Batoga, calm down there. It's all good. We just being helpful to one another today. No harm in people trying to correct you if it needs to be corrected. Good deal. All right. Fantastic. All right, there you go, Batoga. Appreciate that respect. Appreciate that respect. Good deal. Okay, so we have problem number 11, guys. We have problem number 11. Let me go ahead and get my screen going on correctly here. All right, I had it all jacked up for a second. We're going to fix it. All right, it's fixed now. We're continuing to simplify, guys. Angry Hermit's in the house. We have log of base 1/6, say is in the house. And we have an argument of 136. That's exactly what we have. So what you can do, guys, is once again, the focus here should be to see whether or not your argument could be rewritten in terms of your base of the logarithm. And in this case, I believe it can, because I see that I can rewrite this as log of 1/6, the base 1/6 here, and let's fix this 6 and get a better 6 going. There we go. And then I can also show that I have the value 1/6 squared. All right. So I'm going to show it this way, right? So that being the case, we end up saying that since the base of the argument is identical to the base of the logarithm, that this once again will be simplified to give us our exponent of 2, which is the answer to problem number 11. All right, you guys are sharp today because you guys already have this answer for problem number 11 already done. All right, good deal. I see Raul had problem number 2. He had 2 for number 11. All right, Batoga had 2 for number 11. Good deal. And we already have people giving us answers for problem number 12 as well. Good job, guys. Good job. You guys are on fire today. You guys are on fire. And speaking of which, if you want to support Fort Bend Tutoring, do not be shy. Go ahead and give us a super chat. I'll give you some love on screen. If you do so, you can use that $sign at the bottom of the super chat. Also, you can use the PayPal donation button or link that you'll find in the description box if you want to support Fort Bend Tutoring and the free content that we provide lately on a weekly basis, guys. Lately on a weekly basis. We used to put out content like once a month or something like that, but we've been stepping our game up and offering you multiple streams and videos weekly. How about that? All right. So we're stepping our game up because you guys are showing us more love as well. And the more love you give us, the more love we can give in return. All right. And share our knowledge with the world for free with your support. Looking at problem number 12, guys, we are going to say, first of all, that this logarithm could be rewritten as log base 5 with the argument 5 raised to the first power. And it's because of that fact that we can use our property that says that as long as your base of the argument and the base of the logarithm is identical, you can simplify that to the exponent, so that gives you an answer of 1. There you go, guys, in a red box. Noah has the logarithmic equation, guys, for you guys to solve. You can check that out, all right, and solve that logarithmic equation that Noah is projecting, guys, all right. See what y'all can do with that problem. We dealt with some logarithmic equations in the reviews that we did recently. Y'all go ahead and see if you can tackle that problem that Noah's putting forth to you guys in the chat there, guys, as I move on to problem number 13. Good job, Noah, giving the chat something to do, since they're flying through these problems so quickly. Here, guys, in number 13, we have log with a base of 3/2. And our argument here is 4/9. That's right. So this is a good problem because notice, guys, it may take a little bit of cleverness to simplify this problem without a calculator, right? Because notice that our base here is 3/2. However, as far as our argument is concerned, you could say that you could rewrite this as 2/3 raised to the second power. You could do that. You could do that. And then in addition to that, you could show that you could rewrite this by saying that you have 3 to the negative first power over 2 to the negative first power raised to the second power. All right. Then adjusting this further by saying that you have 3 halves raised to the negative first power. You could pull that negative first out. That's exactly what you could do. So you'll end up with, I hate that 3 in the numerator. I hate the 3 in the numerator, so we're going to fix it. There we go. So we could say eventually, guys, that you have 3 halves raised to the negative 2 power. There you go. And once we have it written this way, now finally the argument, all right, the base of the argument and the base of your logarithm will cancel out to give you a result of negative 2 for this result here, right here. There we go. There you go. So that's one way to tackle that problem right there. Good deal. Good deal. So Batoga says that is number 2 5 halves. Let's find out. Let's find out. Batoga, you had the problem number 13 correct. Good job on that one. Raul says we have to solve that equation. We will first use the property of logarithms. Absolutely. All right. Yeah, so for Noah's problem, guys, you guys want to start out by using the product rule for logarithms. All right. Where you're going to combine, that's one way to tackle that, is to combine those logarithms on the left side of the equal sign using the product rule. All right, problem number 14, guys. We have the log in base 3 with the square root, the fifth root of 3. So we're going to first of all rewrite this, showing that we have the log with base 3, and I'm going to write this radical in exponential form. So knowing that my base of the radicand there is to the first power, I can rewrite this as 3 to the 1/5 power. So I can do it just like that. And once we have it written this way, now the base of the argument is identical to the base of the logarithm. So this simplifies to the exponent to give you a result of 1/5. And this is our answer right here. Done and done. All right, Batoga. So the answer here for problem number 14 is 1/5. And you may have been solving Noah's problem when you wrote out 5 halves. All right, there you go. But Batoga, you were saying that 14 was 5 halves. Yeah, so I'll have to disagree with that the answer is 1/5, Batoga, on that one. And Batoga sees why the answer is what it is now. Good job. Good job. That's right, Raul. That is the product rule for logarithms that I was referring to. Good job that it could be rewritten by combining that left side into multiplication. Good job, guys. You guys are being very helpful today. I appreciate you guys doing extra work in the chat as well as following along with me in the stream. Good job. See, this is very beneficial for us all. That's right. Let's continue on, guys, because I have a tricky one here for you. I have problem number 15 as we have log base 8 of 32. So remember I said that your ideal situation, guys, is if you can rewrite the argument in terms of the base of the logarithm. And we already know that as far as exponential integers are concerned, integral exponents, that we can't say that x is to a certain power, all right, not as far as an integer as an exponent is concerned, to get 32. So we're going to have to be a little bit more clever as we tackle problem number 15. So let's see how this works out, guys. So for starters, what I'll do is I'm going to go ahead and show that our base of 8 in the logarithm can be rewritten as 2 to the 3rd power. So what I want to do, guys, is I want to first of all show that I know that 32 could be written as 2 to the 5th power. All right. So I know that this is the case here. So let's go ahead and hook this up this way. There we go. All right. So the next thing I want to do is I want to now rewrite the argument using the exact base of the logarithm. So what do I mean by that? I want to show that I can write the argument's base as 2 to the 3rd power raised to a certain power to give me 2 to the 5th power. So what do I mean by that? I want to show that 3 can be multiplied times a value to give me the result 5 that I originally had. So notice I have 3 here that I want, all right? But I want to be able to rewrite that so that it eventually equals to the 5 that I had originally. So 3 times what gives me a result of 5 is the question. So go ahead and solve for that variable. So we're using algebra to help us out, to help us solve that unknown. So I may have walked into the problem not knowing that the value I need to raise this to is 5/3, but now I know by solving for it. So that's the whole point of algebra, guys, is to go ahead and use this equation that you have made up here because we had an unknown. We may not have known what we needed to multiply the exponent of 3 by in order to end up with a result of 5. So that's why you write your equation as follows, and you make up a variable, and you'll say that you had 3 times an unknown value will give me the result of 5 that I had originally. So the first thing I did was I showed that since 8 and 32 had no direct connection there, all right, they have an indirect connection, but not a direct connection using integers as exponents, we could show that since 8 could be, we showed that, that since 8 could be rewritten as 2 to the 3rd power, and 32 could be rewritten as 2 to the 5th power. Okay, so I looked for that common base within. Then to use the same base as the argument here, raised to a power, we were saying that 3 times what will give me the 5 that I had to give me that original 32 value, that 2 to the 5th power. And then we solve for that unknown by dividing both sides by 3 to end up with 5/3 being that value that I need to have as the exponent that will multiply. Okay, because anytime you have a monomial raised to a power, those exponents multiply together. What's going on, Ashley? How's it going? Good to see you. We're just going over some logarithmic properties right now. Thank you for joining us today. And now, guys, since I can clearly see now that the base of the logarithm is equivalent to the base of the argument, that this now simplifies to give us a result of 5/3, which is the answer. Amen, amen. And of course, we have it in a red box. Good deal. All right. So hopefully that made sense to everybody. Good stuff. Say you take care. Understand. Get your food. Get your grub on, sir. Thank you for joining us thus far. I appreciate that. I appreciate that. So we have Fort Bend Tutoring, Mr. Witt in the house. Sayers in the house. Angry Hermit's in the house. Raul's in the house. Batoga's in the house. Ashley's in the house. That's right. Tony and Noah is in the house. Good deal, guys. We're just here doing some logarithmic properties this Saturday. That's what's going on. And we're now on problem number 16, guys. Problem number 16. So with problem 16, we have log with a base of 1/3 with an argument of 27. And once again, our ideal situation is to be able to rewrite our argument with the same exact base that we have for the logarithm. All right. What's going on, Richard? How you doing there? Richard Haynes in the house, guys. Richard Haynes is in the house. That's right. We're going to go ahead and show that we have log of 3 to the negative 1st power as a base. I want to show that 27 can be written as 3 to the 3rd power, right? Okay, so our ideal here is to be able to write our arguments base as the exact base as we have in the logarithm, which means that I want to rewrite this as 3 to the negative 1st power raised to a power. Okay, that's what I want. Okay, in order to get this problem done here, let's go ahead and remove the chat for now, as I need this space. So what happens here is that we'll go ahead and use a variable. This time I'll call it y. And we'll say that negative 1 times y, all right, here we go. There we go, better, must equal to 3. That negative 1 times our variable y. See, this exponent needs to multiply on a value to give me the equivalent value of 3 that I had to show that I had that 27 originally. So we needed to find out what's going on. Jacobine, good seeing you. Good to see you there. We're going to be dividing both sides by negative 1 here. And by dividing both sides by negative 1, we end up with y equals to negative 3. So negative 3 is what we need to have as our multiplication here. All right, that's the thing that we need to multiply the exponents by. Good stuff. Who out there feels like a pizza right now? Pizza's sounding good to me right now. What y'all think about a pizza? All right. In the house. What? Richard got a 95 on your calculus test. Good job, Richard. You're just awesome. I was tongue tied there for a second there. Good job, Richard. Way to go. 95 on the cal test. Good stuff. You are awesome. That's right. Get it straight, Raul. Get it straight. That's Richard that deserves that credit. Jacob Bain just says hello. All right. Angry Hermit is going to be talking about I'm going to eat an avocado. You go right ahead, Angry Hermit. I'm going to stick with my pizza. That's what's up. Hey, guys. Once we have the base of the argument equivalent to the base of the logarithm, this will simplify to give us our exponent, which in this case is -3. Therefore, our answer is being red boxed with the result for problem number 16. -3. Amen, amen, guys. All right. How am I doing today, guys? Guys, let me know in the chat. How am I doing today? Is everything clear? Is the voice coming in clean? Is everything understood so far? All right. Batoga's already challenging the chat saying, does anybody want to compete on the answers? Does anybody want to compete on the answers? All right. What are all the logarithms good for? Angry Hermit, the logarithms are good for solving exponential equations, all right? Because a lot of times when you're dealing with exponential equations, sometimes the numbers can get real big, real large, real crazy sometimes. And so logarithmic form gives us a different way, an alternative to solving an exponential equation. That's what logarithms are good for. So in a lot of ways, it gives us a shortcut to solving an exponential equation. All right, good stuff. Obina also says that logarithms become useful when you work with asymptotic notation in computer programming. Wow, good stuff, Obina, with that one, with that explanation. Richard says e to the x is the inverse of log. Indeed. All right, guys. So now we're going to be looking at a different aspect of logarithmic properties and how to apply them, and that is in expanding logarithmic expressions, taking a single logarithm and writing it as multiple terms in the same base of logarithm, the same logarithmic base. So here, our directions are to write the logarithmic expression in expanded form. And now we have problem number 17. So problem number 17 says log base 2 of x cubed y squared. Obina is already getting started on hers. If not being finished with it, let's go ahead and verify what Obina has, guys. All right, let's go ahead and show Obina some love by putting it back up on the screen here so she could be forever remembered for her efforts in this video here. We're going to use the product rule for logarithms because we have x cubed being multiplied by y squared. All right, so that means that we could expand this first and foremost by rewriting this as log base 2 of x cubed plus log base 2. Now that base must be identical, guys, of y squared. So this is what we have thus far. Let me go ahead and clean my screen real quick. All right. Okay, doing better, guys. So now that we have this, remember that we have an exponential rule, a power rule for logarithms that state that your exponent can become the coefficient of your logarithm. So therefore, this x cubed can be rewritten now as 3 log of that base 2 of x plus 2 times the log of base 2 of y. So not only did I bring that exponent of 3 in front in the first term for the coefficient, I also was able to do the same with the second term. So I was able to bring that exponent on our variable y in front as the as the coefficient for our second term. All right, so I have 3 log base 2 of x plus 2 log base 2 of y. Done and done. Tony says that Noah got a 100 on his logarithmic and geometric test. That is awesome, Tony. Noah, congratulations on your success. We love hearing some feedback from you guys when you guys are doing awesome, like Richard did on his calculus test. All right, fantastic. So we got 100 from Noah. We got a 95 from Richard. Let's keep these A's coming in, guys. Let's keep these A's coming in. I appreciate that. Good deal. All right. Good job, Lewis. All right, that's right, Obina. You got to remember to bring the exponents in front as the coefficients. Good job. That's right. Okay, good deal. So yeah, don't forget that last step right there. Don't forget that last step. So we're not going to leave any exponents showing as we expand the expression, the logarithmic expression, guys. All right. So no exponents other than one on our basis, on the basis of the arguments. All right. That's problem number 17. Let's keep it moving, guys. Let's keep it moving. I have for you problem number 18. What you going to do with this, guys? Problem number 18. We have log base 6 of the argument w to the 4th power. All right, so listen clearly if it looks all mixed up together up there. That's going to be w to the 4th power times the 5th root of z cubed. So the first thing I'll be doing, guys, I don't know about you, but I'm going to rewrite this. All right, and I'm going to show that this is w, that's supposed to be a w there, w to the 4th power times z to the 3/5 power. All right, so I'm going to write it like this so it'll be a bit clearer for you guys. Notice that I rewrote the radical notation as exponential notation, and so it should be a bit clearer to you guys that are looking at it now. All right, that's what we have. From here, we're able to rewrite this using the product rule for logarithms as log base 6 of w to the 4th power plus log base 6 of z to the 3/5 power. Okay, so we could use that product rule to expand it thus far. And remember, I see Batoga already. Looks like he has the answer going. We're going to now bring all of the exponents in front as coefficients now on each term. So that means with the first term, we'll be rewriting it as 4 log base 6 of w, the argument w, plus, all right, let me go ahead and clear this out here. We'll have 3/5 with our log with the base 6 of the variable z. And here we have our result. All right, Batoga, looks like we forgot the coefficient 3/5 in your result there. All right, what do you think? Let's go ahead and red box it, ladies and gentlemen. That's right. No, it's not 3/3. It's 3/5. It's 3/5. All right. So there we go. We got 3/5 in the house on that one, and we got a red box around it. Good job, Raul. Just to be clear, when you're writing your answer, go ahead and just put parentheses around that 3/5, because that way it's more accurate. All right, when you're typing out horizontal like that, put parentheses around the 3/5, and then you'll be a-okay. So we'll know that it's clearly 3/5 times the log of base 6 of z. All right, so try that out next time, Raul. Okay, guys. Let's go ahead and continue with our next problem that we have, which is problem number 19. Problem number 19. I know, Batoga, my 3s and 5s, they look similar. That's why you got to listen up, man. Listen up, because I'll clarify what I have up there. For instance, in number 19, all that looks the same. It looks a little like a hot mess up there. Let me go ahead and explain what it is. Let me go ahead and cite what I have in the problem. We have log base 3 with a quotient x to the 5th power times y to the 4th power divided by w to the 3rd power. Let me say it again, because I know it was all fast and fuddled and muddled. Let's fix it, Mr. Witt. We have log base 3 of x to the 5th power times y to the 4th power divided by w cubed. That's right, w to the 3rd power. All right, Batoga, I've said it several times, so those 3s and 5s should be straightened out on this one. We'll be using the quotient rule. Excuse me. Hold on. Let me get some orange juice, because I'm getting a little thirsty here. All right, much better with the OJ, guys. Much better. No pulp with the OJ, the orange juice. For those that didn't know, we'll be using the quotient rule for this problem, guys. We'll have log with a base of 3 of our numerator, which is going to be x to the 5th power, y to the 4th power, minus, I was about to say plus, minus log base 3 of the denominator, which is going to be w cubed, like so. All right. From here, we'll be expanding the first term because that first term, x to the fifth power, is being multiplied by y to the fourth power. So we can expand this using addition. So we can rewrite this as log base 3 of x to the fifth power plus log base 3 of y to the fourth power minus log base 3 of w to the third power. Okay, so notice the first thing that we did here is we were able to rewrite this using the quotient rule for logarithms, and then we next used the product rule for that because we had x to the fifth power multiplying on y to the fourth power. All right, there we go. So now all of our exponents will become coefficients. That's right. That's right, Batoga. So when you multiply, you add, and when you divide, you subtract. That is correct, Batoga. That's exactly what we're saying. So we end up with 5 log 3 of x plus 4 log 3 of y minus 3 log 3 of w. And this, that w though, see that w? That w needs to be better. It's better now. And let's go ahead and red box this thing because this, guys, is our answer. There you go. There you go. Now, you cannot cancel out the 3 log 3 because the argument has to be a 3. See, our argument is w. So they were asking, guys, Batoga was asking, I believe. No, it was Obina is asking, can we cancel out the 3 log 3 here? You cannot. You cannot. The only time you can cancel this out is if the 3 was here as the argument instead of that w, Obina. That's when you would be able to cancel that out. Oh, yeah. So here we end up with the following result right there. Okay. There it is. Yeah, the argument has to be identical to the base of the logarithm. That's when it can be simplified. All right. And then Lewis says your y should be a w. I believe he's talking to one of you guys because my y is correct and my w is correct. All right. So I think he's trying to help somebody else out. All right. Good deal. Correct me if I'm wrong, Lewis. Okay. That was problem number 19, guys. What do you think? I think that was a decent problem, right? Good problems. We're warming up here, guys. We have next problem number 20. Problem number 20 now. And with problem number 20, we have log base 4 of the quantity of the quantity x to the third power plus 5 raised to the 2/3 power. That is log base 4 of the argument x to the third power plus 5 raised to the 2/3 power. Let's see if we can fix the there we go. Maybe we can get that a little clearer to you guys. Maybe that'll help. Let me know if that helped out, guys. And that's thanks to Lewis showing me how to focus my webcam. All right. Good deal. Good deal. All right. Let's continue on with problem number 20, guys. Let's get crack-a-lacking on this problem. So for the problem here, number 20, we're going to first of all bring the exponent of 2/3 in front. So this becomes 2/3 log base 4 of x cubed plus 5. Notice that within the parentheses here, guys, that we have a sum. Right. We don't have a quotient. All right. We don't have a product here within the parentheses. All right. No problem, Lewis. So therefore, we can't do anything else to this. All we could do to expand this problem was to bring the 2/3 in front. That's it. Can't do anything else. Can't do anything else. Now, it would have been interesting, guys, now that I'm thinking about it, if they would have made that 5 and 8, in other words, made the argument into a, that would have been really cool. Made this argument here into a sum of cubes. That would have been interesting. All right, that would have been really interesting because we would have been able to factor that, and then we would have been able to use the product rule from there as well as the power rule indeed. Oh, that would have been cool. Now I'm jealous. We should have had that problem. All right. What do you think, guys? Should we do one on the fly? let's do a problem on the fly here. Let me go ahead. Let's go ahead and wrap this one up real quick, right? Okay, and let's see if I can make up a decent problem for us. All right, let's do that real quick. Let's do that real quick. I'm gonna make up a problem and see if we can work it out. Okay. All right, good deal. All right, so here we go. We're gonna call this one WIT 1. All right. So this is not one of the numbered problems. This is one I'm gonna go ahead and make up. Okay, I'm excited. All right, so we're gonna change up the bases and everything so it won't clash with the previous problem. We'll say that we have log base 3 of the argument x cubed plus, let's make it 8. Let's make it 8. All right, raised to the 2/5 power. Let's do that. Okay, let's do that. So we have log base 3, okay, of the argument x cubed plus 8 raised to the 2/5 power. So what I want to do now, all right, because it looks like things are not, there we go. All right, that's better, more focused. Okay, good deal. All right, so here we go. And now let's do the following. Let's go ahead. Let's not rush this, right? Let's go ahead and show that we have log base 3. Hold on, I gotta get my ink right. I gotta write in black. Here we go. Let's show that we have log base 3 now, okay? And we're gonna show that the factorization of the sum of cubes within is going to be x plus 2 times x squared. All right, that's supposed to be a 2 right there. X squared minus 2x plus 4 raised, all of this is going to be raised to the 2/5 power. Okay, so this is what I have. This is what I have now. What you think? Looking good, right? And now, all right, and now what we'll do is we'll go ahead and bring this 2/5 in front. All right, I'm going to take my time with it. We'll have log base 3 of the same quantity, which is going to be the quantity of x plus 2 times x squared minus 2x plus 4. And remember, guys, this is the factorization, all right, of a sum of cubes that I used to factor it in that form there. And now that I have this, what we'll do is we'll use then the product rule for logarithms to expand this further. And so we can say that we have 2/5 times log of 3 of the quantity x plus 2 plus log base 3 of the quantity x squared minus 2x plus 4. Okay, so we're looking like this for right now. All right, and once we have this, now you'll distribute that coefficient of 2/5. So now that we have this, we'll have now 2/5 times our log base 3 of the quantity x plus 2 plus 2/5 of that log base 3 of the quantity x squared minus 2x plus 4. And there you go. There's the answer there. There's the answer at that point. There we go. Let's red box this. So this is what I was envisioning that other problem could have been. All right, if that's the case. Because we were able to factor into a multiplied form where we were able to use the product rule to expand it. All right. So that was fun. I enjoyed that problem because I love factoring. Okay. So y'all tell me what y'all think about that WIT 1 problem. What you think about that problem? Was that decent? Let me know, guys. Let me know. All right. Here we go. We have problem number 21. Problem number 21. Obina says, couldn't you first bring the 2/5 out and then factor? Yes, you could have done that. You could have brought down the 2/5 first. Absolutely. Give you the same result, Obina. So you do have some freedom in the order of the properties and laws that you use when you're expanding in a lot of cases. All right. There are some where you should do things in one before the other. But for that particular problem, it would have been no problem if you would have brought that 2/5 down in front at the beginning. But I was focusing on the factoring because I like to factor, you know. But yeah, that'll work. That'll absolutely work. Good stuff. All right. So I enjoyed that, guys. Problem number 21, it says that we have log with a base of 5 of the square root x squared times y cubed plus 4. So the first thing I want to do here, guys, of course, is to rewrite this. This is going to be log base 5 And I'm going to say that I have x squared times y cubed plus 4 all being raised to the 1/2 power. And that's because the index on that square root is 2. Okay, so I'm able to rewrite that by writing it in exponential form with my radicand raised to the 1/2 power. Absolutely. So once I have this, guys, I'm now able to, as Obina said, let's go ahead and do what you suggested in the other one now, Obina. We'll bring down that 1/2 first. So we'll have 1/2 times the log of base 5, all right? And we still have our argument as x squared times y cubed plus 4, all right? And this is the strategy that Obina suggested for our previous problem, okay? All right, Batoga says that last problem was easy. All right, good deal, good deal. Or that this problem is easy, all right? Even better. All right, let's see here, Batoga. Let's see if we can catch up with your genius. At this point, I notice that I can use the product rule. So I'm going to have 1/2 times log of base 5 of x squared plus log base 5 of y cubed plus 4. Let's go ahead and fix that 3, make it more legible. All right, for the people that joined me today. Here we go, right? And in addition to that, we can go ahead and say that we have 1/2 times 2 times log base 5 of x plus log base 5 of the y cubed plus 4. Just like that. And now, once we have this, we can now multiply each term, get our arrows popping. Get your arrows popping t-shirts, guys. Go ahead and check out that online store for our t-shirt shop to get your arrows popping t-shirt from Fort Bend Tutoring. All right, check that out. So what we could do at this point is taking half of 2 is just 1, right? So that just leaves us with log base 5 of x plus 1/2 log base 5 of the quantity y cubed plus 4. And let's go ahead and double check our work with Batoga. Batoga, I got something different on that one. Batoga. Go ahead and check my work and see if I did it right. I believe this is the answer here. Right here. Y'all go ahead and verify that for me. What you think? Nice little orange juice break right there. Clearing out that throat. That was problem number 21, guys. But Tugger, where you at? Did that make sense? What you think? All right, Obina says, I agree with you. Just some extra parentheses. All right, understood. Okay. All right, well, there we go, guys. Divide by 2. Divide what by 2? Let's see here. Why would we have to divide by 2 in this case? Oh, yeah, we're dividing by 2 because of the 1/2. Yeah, I did that. So 2 goes into itself once. That leaves you with the log base 5 of 1. And then we have half of that value of the log base 5 of the y cubed plus 4. We should be good, right? You thought 1/2 plus 2. Oh, we're multiplying though, Batoga. We're not adding. See, the 1/2 is multiplying times everything inside of the brackets. We're not adding it. There you go. Yeah, we're multiplying, not adding. Correct. So in other words, half of 2 is 1. And there you go. Half of 1 is 1/2. There you go. So that's what we ended up doing. All right. So just want to make sure that everybody's on the same page. Thank you for clarifying that. Happy to help. That's what I'm here for. No problem, Batoga. We're getting things wrong today, so we won't get it wrong on the test or when it counts. Good stuff. No problem, Batoga. That's why we're here to learn, sir. You're doing fine. Let's go ahead and move on with 22. You're doing awesome just by being here. So it says to write the sum or difference of logarithms as a single logarithm, guys. So in this part, we are doing the opposite of what we did before. In the previous problems, we were expanding the logarithms. All right, we started out with a single logarithm and we expanded it into several logarithms by using the sum or difference properties within our logarithmic properties that we had there, using those product rules and the quotient rules and all that good stuff, right? But now we'll be applying all of that to these problems, to do the reverse, to write our expressions as one single logarithm. That's what we want to do, all right? So in this one, we have subtraction. Notice that the bases are identical, and the bases must be the same, guys, in order to use your quotient rules or your product rules for logarithms. Those bases of the logarithms must be identical, all right? And in this case, they are, right? So therefore, we could write this as log base 4, and because they're subtracting, we can use that quotient rule as x squared over y to the 5th power. And there we go. And there we go. Boom, Obina goes the dynamite, as she says we should red box that answer because it's on fire. It is on fire. Excuse me, guys. Got tongue tied there. Needed the OJ break. Maybe that dynamite was too lively there, Obina. Something caught me in the throat. That shrapnel got me. That answer just exploded too wildly. That's why we put our answers in a red box. All right, to contain that shrapnel. More of the OJ indeed, Obina. That's what we need in our lives. Let's check out, guys. Thanks, Lewis. I appreciate that. Let's check out problem number 23 here. Problem number 23 is in the house. We have 4 log of x plus 1/3 log of w. Okay, log w there. Minus 7 log z squared. Okay? So with this problem here, we want to rewrite this, all right, as one single logarithm. And we're going to do so. Oh, yeah, we will. We will do so by, first of all, making all of our coefficients exponents. So we're going to start by saying this is log. And notice that we're in a common log, guys. So our base is 10 here. So we have log x to the 4th power plus log w to the 1/3 power minus log z. See, the exponents will multiply. 7 times 2 gives you z to the 14th power, guys. All right. So this is what I have thus far. Using the product rule, these first 2 terms can be combined. So you'll have log of the quantity x to the 4th power, w to the 1/3 power. I hate that w. I hate the w. Oh, what am I doing? I'm exposing the questions too fast, guys. Y'all wasn't supposed to see that just yet. You know, y'all over there hungry for problems. Y'all gonna already have them done now because you've already seen it. All right, let me go ahead and calm down a bit and get this written correctly. Here we go. So we end up with log of the argument x to the 4th power, w to the 1/3 power, minus log z to the 14th power. Okay. And now what we'll do is, because we have subtraction between these 2 logarithms, we can now show as a quotient that we'll have log, fix that g, we have log of x to the 4th power, w to the 1/3 power, divided by z to the 14th power. There we go. There we go. So here we have our result, guys. Done and done. Let's go ahead and put parentheses around there. Make it look a little cuter. All right. That looks cute like that. Yeah. Or you go ahead and show off and put your and put this as, let's see, x to the 4th power. Let's fix this 4. Fix the 4. There we go. Better 4 times the cube root of w all over. Oh, Lord. Better. Oh, that's just jacked up. I should have just left this thing alone, guys. Here we go. That's better. Over z to the 14th power. I don't know what got into me. I thought I could just quickly write this answer the other way, but obviously no. So let's go ahead and red box it. There we go. All right. There we go. All right. So there's that. Yeah. Got a little radical notation in this one. There we go. A box in a box in a box. All right. All right. Yeah, Obina, I know you knew the log, but you got to remember to write it. You got to remember to write it. It's an exact science. All right. So no consolation prizes. All right. You're going to be correct when everything is correct. All right. See, Raul believes in partial credit. I don't, Obina. All right. So Raul will give you credit for that one. I will not. Okay. I needed everything to be there because same thing goes for me. If I forget anything, I don't get partial credit. I'll have everybody saying, Mr. Witt, you're wrong. All right. So I got to make sure that we are on the same accord, that you got to get it right, Obina. All right. Let's look at problem number 24, guys. With problem number 24, we have 3 log A minus 1/2 log B minus 1/2 log C. All right. And if you were paying attention here, notice that these look kind of suspicious because they have that negative 1/2 there, right? They got a negative 1/2 there. Isn't that a little bit suspicious? So let's go ahead and help them out. Let's go ahead and see if we can rewrite this. We'll say that we have log, which is a common log again, right, of a to the 3rd power. Let's say that. Let's factor out the 1/2. Let's do that. Let's see what happens there. We'll have log B plus log C. All right. How you like that? Right? Then let's work inside the parentheses and show that we have that's 1/2 times log of BC. Okay. What you think about that, right? And then because of our subtraction, let's say that we have log of a cubed over this. Oh, no. Hold on. I want to do something else first, guys. Hold on. Let me fix it. Let's go ahead and do this. Let's go ahead and make it an exponent. Let's say we'll have minus this log BC raised to the 1/2 power. There we go. I want to do that first, I think. Okay. I want to do that. And this would actually be around there. There we go. Better. Okay. Now, I'm going to do the quotient rule now. We'll have log of a cubed over the quantity BC to the 1/2 power. All right. And depending on the authors, they'll have you write it as log of a cubed divided by the square root of BC. Now, normally you wouldn't leave a radical in the denominator, guys. And let's go ahead and get rid of that chat so you can actually see what I'm talking about here. There you go. So now you would end up with the following result. Okay. And I did check with the author of this particular problem, and they wanted their answer. They wrote their answer like this. So it's not like they got caught up with rationalizing the denominator or anything like that. They were satisfied with this result that we have before us right now. So that means that either of these, of course, would be correct. But they liked this version right here written as a radical. There you go. The reason why, there is no reason why, Obina, because you very well could rationalize the denominator. You could do that. But the particular author of this problem said the answer was that. All right. That's what they did. I mean, we could. I mean, I'm not scared. Let's go ahead and take this answer. Okay. We had log of a cubed, because sometimes it could just be so cumbersome, the algebraic aspects of the things that you could do with an answer, that the author will just say, hey, if you got this far, you're good. They'll assume that you know how to continue on. They do that a lot in calculus. They'll let you slide with certain things as far as simplifying it after you get to a certain point. But you're absolutely right, Obina. We normally do not leave a radical in the denominator. So you'll end up with the log of a cubed times the square root of BC divided by BC. All right, you could do it that way as one of your answers. Or, Obina, check this out. Who's to say that the value of BC is not a perfect square? So that could also justify you leaving it in this form right here. Manuel says, so I don't know most of this and I don't have the time to stay, but I just wanted to stop by and say thanks for your excellent help in tutoring. My pleasure, Manuel. Thank you so much. And you can also check out the stream. It will be posted shortly after we complete the stream today. All right. So you can definitely check that out. All right. So there you go. There you go. Obina says, if you want to learn, you can stay. Not making you, though. Obina, you're being feisty today. All right, good deal. So that's problem number 24, guys. Obina, you're absolutely right about that square root. But once again, it depends on the author and your teacher. Some of them will definitely let you stop before you have to rationalize it. There you go. There you go. Lewis says, rewatch and donate. Absolutely, Lewis. That's right, guys. If you guys want to donate to Fort Bend Tutoring, then you can definitely say that you can go ahead and use the super chat. Michael's in the house. Michael Burns says, hey, Mr. Whittington, my girlfriend says she likes you. And by the way, and the way you teach. Michael, tell your girlfriend I like her too. And you, by the way. So I like you guys and I appreciate you guys. And I'm going to go ahead and say that I love you guys because I know that you guys are spending time with me that you don't have to. And I really, really appreciate that. So I'm going to go ahead and ramp up my like to a love for you all that are spending time with me and that are definitely watching the content and hopefully benefiting from the content that Fort Bend Tutoring and myself provide to you guys for free, which is once again why we ask that you donate when you can, because that assists us in bringing you more free content from Fort Bend Tutoring. Once again, that super chat donation button is at the bottom of your screen there, as well as a donation link you can find in the description box. Michael, thank you for stopping by and giving me that good news. I appreciate that. All right, guys, let's go ahead and move on to our next problem here, which is problem number 25. And we're going to count this, guys, as our last problem for the day. That's right. We had 25 good problems about logarithmic properties, and you guys helped me out so much on this. I really appreciate your participation. It has been a blessing. All right. Keeping me in check. We have problem number 25, guys. Given that log base b of 2 is approximately 356 thousandths and log base b of 3 is approximately 565 thousandths, approximate the value of log of base b of 36. Well, guys, in a problem like this, you want to start out by manipulating the expression as much as possible. We're given log base b of 36. However, we don't know what that approximation is offhand, do we? So, because we have this unknown base, we're going to have to rely on the given information. So what you can do is you could rewrite your 36 here, guys, knowing your prime factorization of 36 as 2 squared times 3 squared. Okay, and that's just off of the prime factorization of 36. Recall that if you were to find the prime factorization of 36, you can start off with two factors of 36 being, let's say, 4 times 9. And then, of course, you can end up with 2 times 2 times 3 times 3. So as far as the prime factorization of 36 is concerned, and let's clean up those prime numbers there because they look ugly. There we go. This should be a little better. We have 2 times 2 times 3 times 3, guys, that we could rewrite our 36 value as 2 squared times 3 squared. Michael says, I'm busy with your geometry tutorials. Thank you, Mr. Whittington. Take care now. Hey, take care, Michael. I'll be adding some more geometry tutorials to that playlist shortly. All right. Raul has his answer in already, and we'll check that out. And so now, guys, what we'll do is we'll go ahead and expand this using our product rule. Remember, we'll be able to say that this is going to be log base b of 2 squared plus log base b of 3 squared. So this is what we have right now. Okay. That being the case, all right, let's straighten out the screen here, guys. That being the case, we could bring those exponents using the power rule as 2 log b of 2 plus 2 log b of 3. And now we can use substitution, being as though we know the value there, at least the approximation of log base b of 2. They told us that that value is going to be approximately 356 thousandths, right? Whereas the approximation for log base b of 3 is going to be 565 thousandths. So it's at this point, guys, that we go ahead and we multiply this out to give us our results here. So when you start by multiplying that 2 times the 356 thousandths, you'll end up with 712 thousandths. Then multiplying the 2 times the 565 thousandths, you'll end up with 1 and 13 hundredths. And then finally, adding those two values together, you'll excuse me, you'll have the 1 and 13 hundredths plus the 712 thousandths and end up with 100, excuse me, not 1, but you'll have 1, let me fix it. It'll be 1 and 842 thousandths. Done and done. Raul, can you double check me on that one? Go ahead and double check me on that one, Raul. Did I get it right or did you get it right? We said earlier that, thank you very much, Obina. We said earlier that the approximation for log base b of 2 would be approximately 356 thousandths. That log base b of 3 would be approximately 565 thousandths. And so we simplified it as follows. We used our prime factorization of 36. We expanded it after showing that 36 could be rewritten as 2 squared times 3 squared. And then we went from there. Raul says that he got the same answer as I did now. Fantastic, Raul. Thank you. Obina has the same thing that I got, so it should be right. Fantastic, guys. Thank you. Make sure that Mr. Witt is giving the correct answers to the world. All right. I do not want to get caught slipping with incorrect answers during these streams, guys. That's the dangerous part. That's the dangerous part about this. All right, because it's so easy to make a mistake and then it's recorded for all time. Okay, so we want to make sure that the information is correct. The answers are accurate. The process is correct. All right, so that is red boxed, ladies and gentlemen, for problem number 25. And guys, that's going to conclude our logarithmic properties live stream today. And I appreciate you guys so much. As promised, I will have future streams coming up in the near future covering various topics of college algebra. We'll have some more studio videos coming out on various topics, including calculus and geometry and stuff like that. So please stay tuned. Click that bell icon next to the subscribe button, guys. Donate if you can, because that helps us with our free content being offered to the world. And we appreciate every last one of you guys joining us today. So just a shout out to Michael Burns, a shout out to Richard, a shout out to Obina Batulga, a shout out to Droid. No problem, Droid 264. I appreciate you coming by and spending time with us today. Manuel, thank you for stopping by. Lewis, of course. We had our moderator Lewis, Angry Hermit, in the house as well. We also had Raul and Tony and Noah. Thank you guys for stopping by. I really appreciate that. We had Saya and Ashley coming by today, and many, many others. So thank you guys so much for spending time with me, Mr. Witt, and Fort Bend Tutoring. And please rate, comment, and subscribe. Peace, guys. Take care. Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT. Oh yeah, baby. Thanks for watching.